Hi, I'm Art Hadaway with WaterWorld. I'm on the show floor of WEFTEC 2014 in New Orleans. I'm sitting here with Sherry Beeler. She's the Global Product and Marketing Manager for Cheminair. Sherry, thank you so much for being with us.
Thank you.
So Sherry, here we're standing in front of your RL3 impeller, which is a really good solution for preventing fibrous materials and agitators. Can we talk about that?
Sure. This is our side-by-side display, where here you have an HE3 impeller, which is your standard axial flow impeller. As you can see, it's giving you good flow pattern. It's going top to bottom motion, which is exactly what you want with this type of impeller. And over here, we have our RL3, which is also an axial flow impeller, but this is our ragless technology. So it also provides you good top to bottom motion and a good flow pattern, ideal for solids. So this side by side, what it's here to do today is to show you that once you introduce fibrous materials such as ragging, things that like to rag, into the process, your flow patterns completely change and your mixing is diminished. So what we will do is we will add rags to the HE3 display and the RL3 display, and then you'll be able to see how those are affected. So as you can see, now that the rags have been added to the two displays, that the rags are not attaching to the blades or the shaft of the RL3 display, which is exactly what it wants, and you maintain your axial flow pattern. This is our HE3 impeller display, and as you will see, as the rags are introduced into the basin, the ragging is significant on the blades and on the shaft, and because of those additions to the impeller, you are creating solids buildup in the corners of your basin and also not getting your axial flow pattern. Therefore, your efficiency has gone down and your mixing quality has gone down.
And Sherry, what kind of significant threats does this fibrous material pose to utilities, and how is Cheminair steering the ship towards solving this issue?
If you start to gather the material on your impeller, you start to add weight, which then messes with the hydraulics of the impeller. So having the rags, not only is it a maintenance nightmare to get them removed, it also could affect your gearbox, because your additional weight could mess with your critical speed. You could approach critical speed with that additional buildup, with the additional weight, and then you could start to see a significant wobble in the shaft, and then you might start to decrease the life of your gearbox.
Okay, and with that, is there any particular location or project where these impellers are being implemented that's bringing a successful solution?
We have had significant success in Pinellas County, Florida, where they actually did a side-by-side of our HE3 and our RL3 next to each other, so they had the same flows, same solids, same ragging issues. After 8 weeks of operation, they estimated that there were about 200 pounds of rags on their HE3, and the RL3 was completely clear of all rags. So not only will this save them maintenance time, but it will also save them the life of their gearbox.
And I'm now standing with Kevin Walsh. He's the sales director of Cheminair. Kevin, thanks so much for being with us.
Thank you for your time.
So we're standing here with the UltraTab mixer.
Yes.
Tell us a little bit about that.
Sure. It's a mixer that is used for turbulent flow applications, and it comes in its housing, variety of materials. What we're looking at here is a fiberglass mixer. The general arrangement is you have one singular tab located inside a pipeline that does the mixing. Also has an injector for chemicals, which is what you add to the main flow, and that performs mixing 3 pipe diameters downstream.
And this is conducive for more turbulent flow applications, is that correct?
That's correct, which is normally seen in water treatment type applications and desalination applications. The single flow, the flow comes past the tab, and it performs the mixing downstream of the element.
So Kevin, with that, these mixers are designed for more space optimization, pipe run limitations, things like that. Let's go into that.
Yeah, that's correct. The length of a static mixer is highly dependent on how many elements you have. This has a single element, and it can come with flanged ends, and it really compacts the space, which is excellent for areas that you have to fit a mixer into a very space-limited application or pipe run. These are easily installed in and out, and it really compacts the space.
And how does the mixing work?
The mixing works by injecting your additive into the main flow, which is coming out at you here. So you meter in the mixing, and it actually is injected backstream of this element. And it goes through the high energy dissipation zone predominantly. It has to go through that zone because it's injected backstream of the mixer. So once it goes through and around this tab, it forms turbulent vortices, and the vortices perform the mixing, and 3 pipe diameters downstream, you have a complete mix.
So Kevin, what does Kemenir really have for the future going forward with the mixer as well as the impeller?
Sure. The goal of the mixers we have is to get into different and new markets. So one area right now, especially with the drought in California, is the availability of drinking water. This is excellent for desalination type applications where you can get drinkable water from basically the salt water in the ocean. And with the RL3 impeller that Sherry showed you earlier, it is to basically make maintenance and simplify the operations of water treatment plants.
Great. Well, Kevin, we really appreciate you meeting with us today, and thanks so much.
Thank you for your time. I appreciate it.
And for WaterWorld Magazine, I'm Art Hadaway. Thanks for watching.